Using electricity. In the end, that's what transmission and distribution are all about. Everything we've seen so far is designed to serve this single purpose, delivering electrical power to the homes and businesses where it's used. It's all to get the power to the customer. Power plants, switch yards, transmission lines, and substations. This long journey is in its final stage. Distribution lines form the last link in a long chain. This is the customer's direct connection linking homes and businesses to the power system. In basic terms, the distribution part of a T&D system consists of the equipment and devices that carry electricity from the substation out into the local area and to the consumers who use the power. In many parts of the country, distribution is mostly overhead with conductors strung from pole to pole throughout commercial and residential areas. In other systems, underground distribution systems are used extensively. Underground systems use many of the same components. They're just hidden away underground where you can't see them. For the purpose of our discussion, we'll just consider the overhead distribution lines so you can get familiar with the components and see how to recognize them. The familiar wooden poles are the most prominent feature of an overhead distribution system. They serve to support the insulators and conductors, and they can do it in several different ways. Insulators on distribution poles serve the same purpose as insulators on transmission structures. They electrically isolate conductors and keep them from making contact with other conductors or with poles. This is a pin-type insulator. Pin-type insulators are the most commonly used type for distribution lines. Usually they're bolted to a crossarm. They're shaped kind of like a mushroom and often made of porcelain. Distribution transformers are another familiar sight where overhead distribution is used. Distribution transformers reduce the voltage of electricity from substation levels to a level that can be directly used by consumers. Normally mounted on distribution poles, they have the general shape and appearance of metal cans. On top of each transformer, there are one or more bushings. These bushings are connected to the high-voltage distribution conductors at the top of the pole. These high-voltage conductors are called primaries. They carry electricity from the substation at a voltage of about 13.8 kilovolts. Distribution transformers commonly reduce this voltage to 120 or 240 volts, which is a common voltage used by consumers. 3 or more very small bushings are located on the side of each transformer. These are the low-voltage bushings. They're connected to the conductors that carry electricity at the reduced voltage. These conductors are called secondaries. Secondaries are strung between poles below the transformers. Usually, they'll extend 1 or 2 poles on either side of a transformer. Other conductors are connected at intervals along the secondaries. These conductors are called service drops. Service drops carry electricity directly to homes and businesses. We briefly looked at poles, insulators, transformers, and conductors. Now, another common component found in distribution lines are switches. This is one type of switch commonly used in overhead distribution. It's called a cutout or sometimes a fused disconnect. Now, cutouts are mainly used as protection devices. They interrupt current flow to equipment that could be damaged in the event of an electrical problem. They can also be used to open or close circuits when equipment has to be taken out of service for maintenance. Some cutouts are connected to poles at points in the line where primary conductors branch off toward specific distribution areas. These points are called junctions. Now that we've gone over the major components included in the distribution lines, let's take a look at one simplified portion of a distribution line and trace the path of electricity. These lines represent the high-voltage distribution lines, the primaries leading from the area substation. Again, we're using a single line to represent the 3 phases you'll see in the field. Electricity flows from the substation, through primaries, and to the transformers located around the area. The transformers reduce the primary voltage of the distribution line to a level that's directly usable by the consumer. In most cases, the reduced voltage will be 120-240 volts. In a suburban area, the electricity is then carried by secondary conductors that are attached to the pole below the transformer. Service drops, which are connected to the secondary conductors, carry power from a single transformer to several nearby homes. In a rural area where customers are farther apart, secondary conductors are not used. Instead, the electricity is carried directly from the transformers to a single house using only a service drop. Well, now we've gone over most of the major parts of a transmission and distribution system, from the power plant all the way through to the distribution lines and the individual homes of the consumers. It's a big job, moving electricity all the way from the power plant to the consumers that use it. And as we've seen, it's a long trip with a lot of equipment along the way. As you get more experienced, you'll learn more about how each part of the T&D system works and more about the role you play in moving electricity down the line. The more you look around your own area, the more you'll recognize the components and devices we've seen here. They all fit together in a single system, transmission and distribution.